What exactly is this? Well, it's a vortex.
Why is there a vortex? First, we consider air flows over the aircraft's wing. The shape of the airfoil creates a region of reduced pressure above the wing and comparably higher pressure beneath the wing. This pressure differential leads to a resultant force exerted on the wing, propelling it upwards. Thus, we refer to this upward force as lift. As we know, air always flows from a region of high pressure to a region of low pressure. Therefore, when it comes to the aircraft wing, the natural tendency is for air to move from a lower surface of the wing towards the upper surface. Air moves out from high pressure region under the wing, swirl around the tip, and try to enter the low pressure region at the top. This circular motion is called a vortice. Since it occurs at the wingtip, it's called a wingtip vortex. Furthermore, the vortices aren't just confined to the wingtip. Because of the law of inertia, the vortex extended further revolved from the edge of the wing. This is why you still see the vortices even after the plane lift.
In order to understand this phenomenon more clearly, we have made an experiment to visualize wingtip vortices. In our experiment, we used water instead of air, and we 3D printed a scaled-down version of an airfoil. Sand here is just helping us visualize the effect more clearly. The apparatus we designed for this experiment consists of a gear rack, sliders, a couple of aluminum extrusions mounted on a fish tank, and this is all driven by a Lego motor. This way, we are able to control our velocity, which we will show why it is important later. As the 3D printed airfoil moves up, we can see that there are vortices forming on the two extremes. We can also think of these vortices forming because of a pressure difference. As the airfoil pushes the water forward, it creates a high pressure region where water is pushed and a lower pressure region on the opposite side, just like in airplanes. Fluid particles want to go from the high pressure region to the low pressure region, thus creating vortices.
What are the disadvantages of wingtip vortices? First, it creates drag. Let's see from behind and beside an aircraft. The vortex rotates counterclockwise on the right wingtip and clockwise on the left wingtip. The rotational movement causes the airflow passing over the wing to deflect downwards, and this deflected airflow is called downwash.
Why is it important? That's focusing on the side view of the aircraft, because the direction of lift is defined perpendicular to the relative airflow. In this case, due to the downwash, the lift doesn't point straight up. Thus, some part of lift is acting backward in the horizontal direction, pulling the aircraft back, and this is called induced drag. Second, it creates wake turbulence. As we can see in Top Gun Maverick, these high-energy trailing vortices proceed in the air long after the aircraft has passed by. If other aircrafts were to be behind these vortices, their flight stability would be impacted. How to reduce wingtip vortex?
A common way is to utilize a winglet, which generates a small portion of lift and acts as a wall, preventing the air flowing from a high-pressure region to a low-pressure region. There are different types of winglets. The winglets improve fuel efficiency by reducing the wingtip vortex. Though the winglets does act as an additional source of parasitic drag, the benefit of improving fuel efficiency is much greater than the loss caused by parasitic drag. That is the reason that winglets are commonly seen in aircraft designs nowadays.
To test if winglets are effective at reducing wingtip vortices, we performed another experiment. Here we have a side-by-side comparison of two scaled-down airfoils, one with winglets and one without. Both were operated in the same environment with the same height and speed. Now we can see that the vortex formations on the airfoil with winglets are much smaller than the formations on the airfoil without winglets.
Why don't fighter jets have winglets?
We have been talking about winglets all this time, but if we take a look at the fighter jet that Tom Cruise was flying, why does the FA-18 not have winglets? Well, that's because these designs make the aircraft more stable. In other words, the aircraft are less maneuverable. It's obviously not good for a fighter jet to combat an enemy. So, the FA-18 doesn't have wingtip device such as winglets.
That's all we have on Wingtip Vortices for you.
Thank you for watching.
Hope you enjoy your video. Why do we know all of this?
That's because 我们有修过
陈玉斌老师的基础的留学。